Hi all, in this particular video we will see what is algorithm, flowchart and pseudocode. These are very important for the any programming language. So in order to write a program we need to have a clear idea. So that clear idea or step by step procedure we called as algorithm. Let's see the definition first. An algorithm is the step by step procedure which is used for solving a particular problem. This is called an algorithm. So algorithms are everywhere. For example, if you want to make a tea, so there are some sequence of steps to be followed for making a tea. So in such a way that in programming also there are some algorithms. So first of all, if you want to calculate area of triangle, what and all inputs are needed, what is the formula for that? So we need to give a proper set of instructions to the computer. So these step-by-step instructions are called as algorithm. So let's try to take some examples. The first one is develop an algorithm to find the sum of two numbers. The step number one is we need to start the algorithm, and step number two is we need to input the two variables. So for every algorithm, one or more inputs are required. So in this particular problem, we are taking two input variables called a comma b, and in step 3 we are calculating sum a plus b, and the result whatever we are getting, that will be stored in the sum variable. And in step number 4 we are printing the sum, and step number 5 we are stopping the algorithm. So we'll see another algorithm called develop an algorithm to find the average of three numbers. Here also, for averaging of three numbers, what and all steps to be taken care? Just a second. So first of all, we need to take input of three variables a comma b comma c, and we need to calculate sum by taking the sum of a plus b plus c, and we are storing it in the sum variable. And step number 4, we are calculating the average. So what is the formula for average? So some of the observations by number of observations that we have studied in the schooling. So the same formula we are applying here. We are calculating sum by 3, and whatever the result which we are getting, that will be stored in the average, and we are printing the average to the output window, and we are stopping the algorithm. So likewise these algorithms will work. So we'll take another example. In this example, we are calculating Celsius to Fahrenheit. So we are inputting the Celsius, that is called temperature units. These are Celsius and Fahrenheit. We are inputting the Celsius value, and we are converting that Celsius value to Fahrenheit. We have a formula in our childhood or in schooling. We will be doing this, right? So we are starting the algorithm. And step number 2, we are inputting the Celsius value. And step number 3, we are calculating the Fahrenheit by taking the input of Celsius. The formula is 9 by 5 into Celsius plus 32. And whatever the result that we are getting, that will be stored in the F variable. And we are printing that Fahrenheit value to the output screen. And lastly, we are stopping the algorithm. So this is a simple algorithm, right? So we'll see the step number, example 4. Here we are dealing with the conditions. So as far as we have covered some examples, right? We didn't encounter any conditions. But in this example, there is a condition. So if that is true, that particular section block will be executed. So these are conditions. These conditions will be discussed in the unit number 2. Just for sake of understanding, so we are starting the algorithm. This is the algorithm to find the biggest number in three numbers. So if you are taking three numbers, we are calculating what is the big value among the three numbers. First, we are inputting the a comma b comma c values, and if a greater than b and a greater than c, that means if a greater than b and a greater than c, if that conditions are true, we got a conclusion that a is big. Okay. Now step number 4, if b greater than a and b greater than c, then b is big. Otherwise else c is big. So this is the simple algorithm to find biggest of three numbers. And the algorithm to find sum of n numbers, which we will discuss in the next unit, because it involves the looping constants, looping constraints. So this we will discuss in the unit number 2. Now let's see the flow chart. So in order to represent algorithm diagrammatically, so let us see the definition first. The graphical or pictorial representation of an algorithm is called flowchart. So whatever we have discussed, what is algorithm, the step-by-step procedure. So that step-by-step we need to denote it with the diagrams. The flow, that flow we can describe in one particular diagram called flowcharts. So what and all symbols which we can use as part of flowcharts. This is vowel. Vowel indicates start or stop, and this is parallelogram. So parallelogram is mainly to take the input and to display the output, and rectangle to calculate something, or to calculate process, or to calculate some mathematical formulas. We are taking rectangle, and the diamond or rhombus for decision making. That means if you want to calculate some conditions, if you want to check some conditions, then you can use diamond or rhombus. And to continue the flow between two boxes or between two steps, we can use arrow marks. This is called flow of control. And we rarely use these things. This is called connector symbols. For example, if the algorithm is too big, and if you want to divide the algorithm in two sides of one page or one paper, then we can use a circle connector. And there is one more concept called off-page connector. That means if you want to continue the algorithm in the next page, then you can use this inverted hexagon or whatever you can call. This is called off-page connector. Normally these things will be come into picture when the algorithm is too big. Okay, so let us see some examples so that you can understand how to draw flowcharts for different algorithms. So in this algorithm, we are, as we can already see in the previous slides, so this is called sum of two numbers. First, vowel to start or stop. As we can see in the previous slide, vowel to describe start and stop of an algorithm. So we are starting the algorithm. We are reading the two variables called a comma b, because since these are input values, we need to draw a parallelogram. Okay. So we already seen in the flowchart symbols, right? So then we need to calculate sum by taking the summation of a plus b. Sum is equal to a plus b, and then we are printing that sum. For printing also, we will be using the parallelogram only. Okay, then we can stop the algorithm. So this is one example for flowcharting of sum of two numbers. Likewise, we will see average of three numbers quickly. So we are starting the algorithm by taking the vowel symbol, and we are inputting the a comma b comma c values. And since calculation is required, for calculation and all, we will be taking rectangle symbol. Sum is equal to a plus b plus c. And what is the formula for average? Sum by 3, because these are three observations, right? Sum by 3, and whatever the result which we are getting, that will be stored in average. Finally, we are printing that average value to the output screen, and then we are stopping the algorithm. So that's it for flowchart and algorithms. Now let us see the pseudocode. A pseudocode is an informal way to represent an algorithm. So there is a concept of syntax. Syntax means programmatical rules. So in order to learn any programming language, we need to learn the syntax first. So that is basically a grammar for the language. So as part of pseudocode, we won't be concentrating on syntax. So we will describe the algorithm informally, that is called pseudocode. Now let us see the definitions first. Pseudocode is an informal way of describing the steps of program solution, or simply you can say algorithm, without using strict programming language syntax. That means you cannot bother about the syntax. Just whatever you have understood, you just put it in the English like sentences. That is enough. That is called pseudocode. There are no rules such as you need to follow these symbols only. There is no such rules because we do not concentrate on any language syntax here. And pseudo means fake, and pseudocode is nothing but a rough code. And in this we can use English level statements. So let us see the pseudocode now. So for sum of two numbers, we can initialize numbers into variables a comma b, and then we can calculate a plus b and then store that result into the sum, and finally we are printing that sum. Okay, so this is called pseudocode. So as I said earlier, there is no programming syntax rule at all for this. You just freely write whatever you have understand, but the main aim is to that whatever you have written as part of the pseudocode should be logically correct. That is the only aim for pseudocode. So now let us try to describe about structure of C programming language. Very important. So in order to write any C program, there is some format to be followed. That format is called structure of C program. Okay, so C language is a structured programming language because C program is divided into functions. Because so take a one problem and divide it into subprograms. Those are called functions. So C programming is mainly dependent on functions. So this is a structured programming language, and the structure of C program can be mainly divided into 6 parts. The first one is documentation section, the second one is linking section, third one is definition section, fourth one is global declaration section, fifth one is main section, and sixth one is subprogram section. Let us see each and every section in detail. So I will just scroll a little bit. I will use some markers here. Just a second. So as you can see here, the documentation section is a comment section. So like if you are writing one program, so in order to describe that program aim, you can use comments. These comments and all will be part of documentation section. You can, this is not mandatory, but it is suggested. So if you are writing comments means, that means it will be easier for others to understand your code. And in software industry, the comments are very necessary, because for reviews and all, these comments will be coming to handy, so that your reviewer of the code can easily understand what is that code aim is. So comments are not mandatory, but it is suggested to write. Okay, so then next one is link section. Just a second, I will take so for example, if you are writing one program like this, hash include stdio.h, and I will write one simple program here, and I will try to explain what this structure of C program can look like. And I will be writing one main function here, and I will be writing one printf statement here, and I will be writing one return statement here, and I am closing the program. This is a very simple program, but I will try to match this with structure of program. In this program there are no comments. Okay, that comments and all part of documentation section. So comments are two types. One is single line comment and another one is multi-line comment. So if you want to describe what is a comment, you can denote it with two forwarded symbols, or this is a single line comment. By the way, this is called a single line comment. Okay, and if you want to denote the multi-line comment, you can use one forward slash followed by star, and then you can close it with star and forward slash. So you can denote multi-line comment with this structure. Okay, so this is, as I said earlier, documentation section is not mandatory, but it is suggested to write. And there is one more section called link section. Link section is whatever you have written the header files like hash include stdio.h, These are called header files. So for example, we are using printf statements or scanf statements in our programming language. So this printf and scanf is defined in hash include stdio.h to link this functions with the library files. So stdio.h stands for standard input and output header file. To link these functions with the header files, we are using a link section. So link section is mandatory. Okay, so definition section. So to define any symbolic constants or macros, don't worry about the macros. So we will be seeing macros in the further chapters. For now, you just understand there is a concept of symbolic constants, like there is a pi value, hash define pi 3.14. So this is a symbolic constant we are declaring with hash define directive. So these are also not mandatory, but if you have a requirement, you can write it. So these are called symbolic constants. We will see what is symbolic constant in a while. And then next section is global declaration section. So if you want to declare any global variables, so what is global variable, what is local variable, these things will be discussed in a concept called functions. So that global variables can be defined in this section. Okay, so the next section is very important and mandatory section called main function section. This main function section is the entry point of any C program. Without main, there is no C program. So this is very much important. So in this main function, because the compiler starts the execution from the main function itself. In this main function, we have a declaration part and we have an executable part. Declaration part mainly deals with the declaring the variables. For example, we have a variable called int a is equal to 10. Int a is equal to 10 is a variable. So we are declaring to the compiler there is one variable is existing. In that variable, we are storing the integer values. So that is called declaration part. If you want to execute that code, you can use printf and some calculations can be done. That is part of executable part. So in this, we are printing hello to the output screen. That is comes under execution part. And we are returning 0 because the compiler calls the main function. So main function will return a 0. 0 means a successful completion, but you can return any value if you want. So what is the significance of return will be discussed in a concept called functions. This is not the right time to discuss the return keyword. So, and this is a subprogram section. So a function is a block of code which will perform a specific task. If you see this code, we have a printf. Okay, printf is a function, but it is a inbuilt function in C. We didn't write the printf function on our own. Printf is already present. We are just using that. So for sometimes we need to write some functions for our programming requirement. So those functions are called user defined functions. If you want to declare or define some user defined functions, you can use subprogram section. Okay, so this is the part of structure of C program. So let us try to move to the another topic. I will just close it out. Just a second. Now we have discussed data types in our previous videos. I don't want to discuss again. Now I will move to constants. We'll move to constants. A constant is a variable. A constant is a value that cannot be changed during the execution of the program. If you declare a constant, we cannot change that value later onwards. That is the meaning of a constant. A constants in C language are variables whose values cannot be changed during the execution of the program. Once they are declared, they are rock written. We cannot able to change those values. So those are called constants. The constants can be defined or classified into two types. One is numeric constants, and another one is character constants. As part of numeric constants is concerned, we have two different types. One is integer constants, another one is real or floating constants. As far as character constants are concerned, we have single character and string and backslash constants. We will see one by one. And as far as integer constants are concerned, we have decimal constants, octal constants, hexadecimal constants, and binary. So we will see one by one. So we can define the constants by using a const keyword, and we can use a hash define directive as well. We can define these constants in two ways. One is with the keyword called const. Another one is by using a preprocessor directive called hash define. So we can see here. So by using const keyword, we are telling that compiler whatever we are declaring that variable is treated as constant. So here int abc is 100. So on later onwards, we cannot change that value. That is the meaning of constant. And likewise, we are declaring one float value. Float value can be, we can store floating point values in float data type. And this is denoted with const. Const means constants. We cannot change the value later onwards once it is declared. So likewise, we can declare the constants with the hash define directive. So hash define is a preprocessor directive. We can, I already told in the structure of C program, hash define pi is 3.14. Okay, so pi is a constant value which we cannot change it. Okay, so this is a constant value in mathematics, if you can remember that. So we can define the constants in two ways. Now let us see some decimal constants. So decimal constants, we can const int b is equal to 249, that is a decimal constant. This is a valid one. Int c is equal to minus 321, this is also valid one. But when it comes to the third example, this constant value is not preceded with the 0. So that is why this is not a valid octal constant. Okay. Now let's see the hexadecimal constants. Hexadecimal constants are preceded with 0x and what and all allowed digits 0 to 9, A, B, C, D, E, F. These are the only allowed characters in hexadecimal. Now let us see what and all valid and what and all invalid. 0x249 is a valid, 0x321 is a valid. When it comes to the third example, x is equal to 240, but we are not proceeding with the 0x. That is the meaning, that is why this is invalid. For binary, we can precede it with the 0b. The only allowed values are 1 and 0. So we can precede it with 0b or 0 capital B, and these and all allowed examples, and only 1 and 0 are allowed. No more other digits are allowed in the binary constants. Now let us see the real floating constants. So float b is equal to 249.45. So as far as floating points are concerned, we can store the point values like 2.5, 3.5. These values can be stored in the real or floating constants. So these are all valid floating constant values. So let us see the character constants. We can store a character constants, we can denote it with the character data type, and these are constants. So we can have a const keyword before that. B is equal to x. So as far as character constants are concerned, we can store any alphanumeric symbol. So this is valid, and z is a valid character, that is also valid. So x is equal to 2, 3. We can store only 2 or only 3, but not 2, 3. This is not a valid. So we can store a dollar symbol. These are all single character constants. We can have a string constants called literals. So a string is a sequence of characters or an array of characters. So we can define an array with the closed brackets. Now let us try to understand these things. For example, we have a variable called b and b array. So this is an array of characters, and we can store a name here. Let us say Vasvi. So sequence of characters stored in a one array like structure. So if you want to describe in one memory location, VASAVI, and it is ends with a null character. Don't worry about null character, we will discuss in the future lessons. So the index starts from 0, 1, 2, 3, 4, 5 and 6. So string constants are generally denoted with the double quotes and character constants are generally denoted with single quotes. That is the difference between string constants and single character constants. So we can have this is the array of characters. By the way, this is the array symbol. What is the array? We'll discuss in the unit number 3. So